And we'll have a bit of a walkthrough of these es460cs. Right, we've got two boards flipped over, mirror. So that side of the board is this side of the bottom board. We've got our connectors. Take him out. And now we'll just have a look through. Got two mobs. The front one's covered in a piece of heat shrink because if it goes ballistic it may actually draw an arc between the two, and the case is just along here, so that's pretty close. And so they do that. Someone goofed up over here on the gas arrestor, goes through the hole there, but there is the actual through hole, so someone goofed up. So down here they had to mod it onto the ground rail. This is the ground rail, your earth reference. Then we've got our two reefers, the shot, high quality capacitor, another inductor, high quality capacitor, inductor. We go to this fuse. These reefers aren't really there in the circuit. If you look down here, that's them just across there, but they actually take their feeds from way back up here in the middle of this lot. I suppose they thought, well, if we're going to put something that's going to blow up, we may as well put it where it can blow up and not cause too much damage. Oh, bloody hell. We go through this fuse and then we go to this relay, and there's two thermistors here for inrush current control, and that's what the relay is all about down here. Okay, when she powers up, the power goes through the mobs to get all this stuff hot, and then when it deems good it just switches straight to direct, so it's current control. The other power supplies, that's one there, it comes across to here to this transistor, and that regulates the power supply for the PFC and everything else on that hot side. It also instantiates under here and ends up over here on this full wave bridge lot here. Then it ends up at the 7805 just in here, and that powers all the logic plus just there. 16C 620 pick, so that's where it gets all its power from there. Over here we go through this big inductor, and this is the power factor control circuit. On this daughter board here we've got a 2901 comparator and a UC 2584 power factor correction chip controller, and then it's actually switching down under here to this plate here, on the back of which are two MOSFETs and a diode over this side. And that power is coming out here and into this bulk cap. Okay, now up in here, this is all our snubber gear for the MOSFETs on the bottom, which are these four under here, full wave bridge controlled. There's our pulse transformers. There's our phase transformer. All this stuff's being controlled by, get out of the way while that chip down in there, which is a UC2875. You can look it all up. It was all really basically straightforward. You know, it's like, here's your main switching transformer here, and then there goes the power supply. That goes into there. That's where the switching inputs are. Across the transformer out to here. And I thought, okay, that's fairly catchy. And you've got both sides of the transformer going into this double diode and coming out on the center pin here. What had me confused was this center tap rail comes over here, goes back around here, across here, which I couldn't work out originally. That's actually that inductor in there, which I later discovered is a shim inductor to keep the frequency of the whole circuit in tap. When I looked a bit more closely, down in here, the black resistor, it's R0.15, and it's actually used by this chip in here I said that was interesting. This is the UC2907 current share controller, and that keeps all the power supplies at a constant shared load into the batteries that they were doing. We've got quad amp here, we've got a quad comparator here, and what else have we got? Oh, this guy up in here, this is actually LCM 6028, a precision op amp, and this is the thing that you're connecting the external circuitry to get it to do whatever voltage you want. But in real life, this is talking to every other unit in the block to give it the current that's actually going, and it receives a signal back telling it how far to drive this thing. This secondary here is actually the output inductor. It's just single wound on one side, there's no outputs on this side, so it's just an output inductor, which is whereabouts on the board there. Just there, comes off the center, goes through the inductor and comes back here. And that's what confused me, because I was trying to work out what was going on here. But it's just a topology. If you look up the chip numbers, I'll put them in the description, you can see what they've actually done. Apart from that blue there was something else. Oh, see the ends of these wires here for the LEDs. No, they're not just poked through, they've actually got crimped ferrules on the end of them. So a lot of work there. Not going to go in there. I know what it's doing. I think that was pretty much all of it. One of them had, get out of it. One of them actually had one of these transformers singed by when someone went in here to solder on the switching MOSFETs for the full wave. But otherwise, it's all pretty straightforward. There's the ferrules poking through. Oh, these friggin' things. These frame locks. If you look up here, you see they actually extend underneath the case for the frame lock. So I don't know if I'm going to leave them off or just grind them back to that line. See that line there? If I just grind off the clasp, it'll be flat with the bottom of the case, and that might work a bit better. Here's your mains in over here, separation gaps, there's your earth, There's your Mongol, there's your 48s, your high volt, your 50 volts out, whatever you want to call it. Secondary supply. And here's all the control to set the voltage. And most of the pins down here totally unused. Oh, can we see that? That's the sticker that was on the pick. AT&T H05. But anyhow, we've got all our caps. Finland, Finland, Finland. And what else we got? Made in the home country. Yeah, we can go for a rework now and fix all these reefers. Get one of these units up. Have fun.